much greater reduction in size, right? We're talking about the whole thing this size to something the size of, well, I can't even see it. It's not even printable on there, right? Okay. The sun to a planet, you can see both of those, can't you? We could put the sun and we could put the planet up on the wall and we could see them both and go, yeah, okay. But this is like here. So that's reason number one, is that it's a greater reduction in size. Reason two is that you're starting out with stuff that's really, really dense. Degenerate matter is incredibly dense. Not neutron star material, but it's really, really, really dense. Right? You know, thousands of times more dense than anything that we've got on Earth, right? Okay. So it crushes that all the way down. It will, a star that does this is called a supernova. Okay? And again, we have some dramatic, I just want you guys to brace yourself emotionally. There's some dramatic PowerPoint animations here. Okay? And I want you guys to be emotionally ready for these. Okay? Right? So as soon as it cools down, if it's greater than 1.4 times, it's going to do a supernova. Right? A supernova is where it collapses from a planet to something the size of Portland, right? Okay. And the crazy thing about a supernova is that for a few days, like a week, okay, a star can be brighter than an entire galaxy. Let me say that again. A star, one single star, can be brighter than an entire galaxy. The galaxies have 100 billion stars. The star becomes 100 billion times brighter than it was. If you looked at a galaxy, even if it was a faraway point in the sky and you couldn't see the stars in the galaxy, that galaxy would get twice as bright. People notice things like that, yes? Don't they? In fact, they've used this. There are supernovas that have happened in galaxies near us that people have seen them in the sky and go, what the heck is that? Right? The word disaster means bad star. So people are fantastically astronomy, right? Yes? Do we know this, right? Okay. So yeah, there's in Central America, right? The Mayans or the Incas, right, had noted the certain supernovas in the sky. They've seen them in China and they've seen them in Europe, right? And so this has helped historians actually take events and pin them to the same time, right? It was like near the supernova. It's like a little thing. It's a pin that goes through all those historical timelines. It's pretty hard to line them up otherwise, right? Because we nearly like lapsed into the Stone Age. Somebody has a question? No, nobody does. Okay, did you see that? Huh. It's actually not that good. Here, watch. Hold on. Here. Right? Okay. The terrific energy, so this is the crazy thing, right? How does it do that? Well, here's how the Pauli exclusion principle, we don't have a problem with that, right? The Pauli exclusion principle says that two electrons cannot occupy the same state. It's still upheld, but what we do is we stick the electrons into the protons, right? So all the electrons that are running around, we just stick them into the protons. If you add an electron to a proton, what's in that charge? Neutron, it's neutral, right? You can make neutrons that way, not ordinarily, right? But in this situation you can. So you make neutrons with them. The other thing that happens, if there are any dogs actually become cats, okay? Republicans support campaign finance reform, and Democrats actually cut taxes only in those situations, okay? Okay. In 1987, a supernova occurred. It was only visible in the southern hemisphere. It was in the Large Magellanic Cloud, right? And people could see it at night, right? They could just say, what the heck is that, right? Okay, well, they knew what it was, right? Assuming you were in Australia, right? How about the star, like the Star of Bethlehem, right? In the birth of Christ story, yes? There's actually there's some astronomer that thinks that was actually a supernova, that there was a supernova around that time. And the crazy thing about it is it's this new star, and it would appear to be, over there, right? So it's, it's kind of an interesting thing, right? Here is supernova 1980. How do you suppose they name these supernovas? 1987A. Yeah, here you go, right? Actually, not the year they happen, but the year we see them, right? There's a subtle difference there. But astronomers always say it's happening now, even though it happened 2 million years ago, right? It's like old people, right? Okay. This is a picture in 1994. This is a picture in 1997, right? And the cool thing is that this ring is moving out Here it's just encountering a little knot of material. Here it's moved through it, right? So these rings are just like in the Star Trek animations, the explosions, those rings that go out like that, or Lord of the Rings, right? They cut off the ring off Sauron's hand, and kind of a thing. Why there's multiple rings? Not so sure. Not so sure why that is. We still don't know. Okay, we've got ideas, but we still don't know. Okay, here's a picture of this is the Whirlpool galaxy. Some students had a picture taken. They said, "Hey, I need a picture for my PowerPoint presentation," and that picture. When they happened to take it, they caught a supernova. That star right there wasn't there the night before. Yeah? That's crazy, right? Okay. So, and there's supernovas are fantastically interesting to astronomers for reasons we'll talk about next time or the time after. But what they do is what you do is you just look at a galaxy. If there's a new star in the galaxy, right, then that's a supernova. And these people have memorized all the stars. Usually a bright star like this is actually in the Milky Way. It just happens to lie in front of this galaxy. Like that's probably a Milky Way star that's just in front of us, right? This one's 100 light years away. This guy's 2 million light years away or something like that, right? Okay. So anyway, neutron stars basically spin thousands of times a second, right? Okay. And so, gee, what would a neutron star look like? Well, it wouldn't emit any light, but it would be spinning really fast, right? And so the story goes like this, right? Anthony Hewish of Cambridge University, he's studying, basically what he wants to do is, his study is that the solar wind, when the sun's radiation and charged particles from the sun hits the Earth's atmosphere, that is a radio source. It creates its own radio waves and basically makes a lot of interference. Radio telescopes are these incredibly sensitive radio receivers, yes? Enormous dish. You've got a dish this big on your house to receive cable. Those things are like, there's one built in Arecibo that's like the side of a mountain, right? Just ginormous, right? Incredibly sensitive. And so his study, he's not even really doing anything about astronomy. He's trying to reduce a source of radio interference. So what he does is he gives his graduate student, somebody's got to stay up all night and do this, right? So who's going to do that? Hey? Who's going to do that? Is it going to be the guy with a PhD, or is it going to be the graduate student? Graduate student's going to stay up all night and point the telescope at random places in the sky and measure this interference, right? Okay? And so Jocelyn Bell Burnell, she discovers randomly, just points the thing up in the sky, she discovers this little if you point your telescope into the sky and you suddenly hear pip, 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 what are you going to do? Yeah, you're going to either think it's from out there, or more likely, if you've never ever discovered anything like that in the night sky, aren't you going to think it's like some motor or something down here on Earth that's like messing you up? Right? Somebody's got a new piece of radio equipment in the block next door, right? So she starts looking around for the source of this thing. She turns off all the motors. She turns everything off. She leaves only the amplifier on. Sure enough, it's still there. And then it goes away. Oh. Then it's like, why did it go away? Well, as soon as you turn off all the motors, telescopes, has anybody looked at through a telescope at something really close? Anybody ever done that? Nobody has? They move, since the Earth rotates, they move, things in the viewfinder move across your view. Yes, don't they? Yes, take my word for it. When you zoom way in, same is true with a telescope. So that's why they're all mounted on these things that they can slew, right? And they've got a clock that runs, and they just sit there and track the objects in the sky. As the Earth rotates, they rotate the other way. When she turned those off, well, suddenly it went out of view, right? It's like, so then she goes back to the same coordinates, there it is again. Right? She's discovered this thing. It's in the night sky. The only thing that can spin that fast is a neutron star. She's discovered it, right? Or did he discover it? I don't know. She did. She discovered it, right? There it is. Bip, 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 right? Incredibly fast, right? And the only thing that's small enough, it has to be small to spin that fast, would be a neutron star, right? Okay? So this is from my book in 1970. They weren't sure whether they were shot off tangentially or axially. Now I believe they think it's axially. So let's just look at an animation of this. Okay, animation. You could not open the specified file. Well, just try to open it. Try to open it. No, not there. Okay. Oh, they're not.